Yes, student. Good afternoon. Welcome to Filo. Okay, let me have a look at a question over here. In wide DSC setup, if the path difference at P and Q is lambda by 2 and lambda by 8, find the ratio of intensity. Okay, fine. Got it. Okay. So see, over here, what is my intensity formula? The intensity formula is, there are two formulas, but I will use the cos square one. Okay. I is equal to 4 times I naught cos square phi by 2, right? Over here. That's the formula. Now, as you can see, in order to find the intensity, I need to know my phi over here. So I need to, so before I can calculate intensity, I need to calculate phi. That is the phase difference. Okay, this is del phi actually, not phi, del phi. Yeah. Now, how do I calculate my phase difference? As you can see, the path difference is given over here. So I know that phase difference is 2 pi by lambda into the path difference. So I can use this relation, I guess, over here. So my phase difference is 2 pi by lambda. And what is the path difference? Lambda by, first is lambda by 2. So keep it as lambda by 2. So it is uh, pi over here. Okay. So the first case over here, for case 1 over here, my phase difference phi 1 is pi. Now plug this value over here. So what do I get over here? I get I is equal to 4 times, is it lambda by 2? Yeah, 4 times I no, sorry, why am I writing pi over here? Wait, 4 times I naught. Yeah. It is cos square. Now phi is pi by 2, which is cos square pi by 2 is 0. So this is 0. So my I1 is 0. Similarly, what will be I2 over here? I2 will be same thing. Cos square 4 times I naught. Cos square phi 2 by 2, del phi 2 by 2. Find out this way, del phi 2. It is 2 pi by lambda. What is the path difference over here? It is lambda by 8, which is pi by 4, right? So I get pi by 4 over here. So plug in the value over here. Okay, so it is 4 times I naught. Cos square, it will pi by 4. It will become cos square pi by 4. So it will become pi by 8 over here. Okay. But now see, look at the, see, we cannot calculate pi by 8 over here. Okay. But look at the options. The intensity option A is 0 over here, and I already got I1 as 0. That means that's my answer, right? Because I1 by I2, yeah, I ratio about, yeah, sorry, I1 by I2 is 0. Yeah, that is the answer. I hope the logic is clear. Yeah. Okay, let's look at the next question over here. Yeah. Yeah. Okay, let me look at the next question. I think you sent another question over here. Let me see. For small displacement. Yeah, this is a tricky question. Yeah. The period was, see, the problem over here is your k is the k is perpendicular over here. Okay. Okay. See, what I maybe what we can do over here is first, I want the time period. So what is the time period over here? T is equal to 2 pi root of m by k, right? That's the formula. But now my k's will be what over here? Yeah. Yeah. Okay. Uh, M is fine. M will be capital. That's fine. That's not an issue. But K will be what? Okay. Let me think. Let me think. So let me just read out the diagram. 30. This is 30 over here. Okay. So now this is 30. This is 90. This will be how much? This will be 60 over here, right? Yeah. Correct. Okay. I'm just drawing like a diagram over here just to figure it out. So over here, my displacement will be different over here. Okay. Net time period. This will be over here. This will be cos 60 over here. Okay. Just hold on. Let me think. Wait. 2 pi root of m by 2m. Yeah. Something related to the angles we'll have to do over here. Wait. Huh. Omega. What is my net displacement over here? Oscillating spring is fine. This is cos k2. This is cos 60 over here. This will be x cos 60 over here, and this will be x over here, right? So wouldn't be it wouldn't be like this over here. It will be 3 by 2 x cos 60, right? Sorry, 3 by no, sorry. It will be x by 2 plus x over here, which is 3x by 2. Okay, so I know that acceleration is omega square. So I can say omega square 3 by 2 I'm getting over here, kx over here. F is over, f cos 60 is over here and f is over here. Okay, so f cos 60 plus f. So kx cos 60 is half plus kx, right? So basically I'm getting k 3 by 2 x, right, over here. This I'm getting over here. So this is my k. I think this is my value for k over here. 3 by 2 k. Okay. So t is equal to 2 pi root of m by what is 3 by 2 k, right, over here. So it will become 3 by 2 k. So it will be 2 pi root of 2m by 3k. Is there an option like that? 2m by 3k? Just check. No, there is no option that. No. Okay. Then what mistake? What is the option? 4 by 5 and 1 by 4. Okay. Hmm. Cos 60 is over here. 30. This is 30. Hmm. I've taken everything properly at over here. K is given over here. Kx. Maybe my displacement is not right over here. I guess. I guess. I guess it's not right over here. Maybe that's the mistake I'm making. X cos 60. Do you have the answer for this one? I'm not 100% sure for this one, but let me think. Um, wait. Not given. Okay. What else can be done over here? Wait, let me think. Can I use this? They want displacement, right? Over here. No, they want time period over here. Hmm. I made a small displacement delta x over here. This will become delta x by 2. Okay, I'm very sorry, student. I'm not sure for this one. I'm not sure for this one. I'm not getting the answer over here. No. I guess what we can do is okay. Here's another one. Okay, and equal. Let me see. Okay, we can get back on that question later. Okay, we can just do this one first. Okay, and equimolar. Okay. Ah, see, if it's equimolar over here, first we need to calculate the equivalent number of like equimolar. Basically, the number of moles is same over here, right? But how do I figure out the this part over here? Wait, equimolar. Mm, yeah, this is correct over here. What do they want? The equation of final temperature. Okay, final temperature to initial temperature. Okay, this will, what we can do is we can first find the equation over here. I think that will be much better over here. Uh, equimolar. Okay, monatomic and diatomic. Okay. First, what will be the equimolar part over here? It is NCP1 plus NCP2 upon N1 plus N2, right? Is N1 CP1 plus N2 CP2 upon N1 plus N2. The number of moles is same over here, so this will become 1. CP, it is monatomic and diatomic, right, over here. So it is 5 by 2 plus 7 by 2. So it is 13, 12, sorry. 12 R by 4, which is 3 R. Okay, I got the equivalent molar value over 3 R over here. Okay, now I want the ratio of what final temperature to initial temperature over here. See, suddenly compressed over here. If it's suddenly over here, it has to be adiabatic, right? Because suddenly compressed. The process is adiabatic over here. Okay, this is adiabatic over here. Definitely adiabatic. Delta Q is 0 because suddenly. Okay, so yeah, it has to be adiabatic. There's no other. There's no other because that suddenly is the keyword over here. Okay. So I want pressure over here. See, I know that in adiabatic, P V raised to power gamma is equal to constant, correct? But I want to remove this pressure. So I'll write P as N R T by V. V raised to power gamma is equal to constant, right? That must become T V raised to power gamma minus 1 is equal to constant over here. Now we can do something over here. Okay. Now I already know the value of Cp is what? Cp is this value. So I know that Cv is what? Cv over here will be Cp is Cv plus R, right? Cv will become Cp minus R, which is 3R minus R, which is 2R. Cv, sorry, Cv. Yeah. Okay. So I got the value of gamma as well. Gamma over here is what? Gamma is Cp by Cv, which is 3 by 2. Okay. Now I got the value of gamma. So I'll have the equation T1 V1 raised to power gamma minus 1 is equal to T2 V2 raised to power gamma minus 1. Now what do I want the ratio of final temperature equation. I want T2 by T1. So V1 upon V2 raised to power gamma minus 1 is equal to T2 upon T1. Okay. Yeah. So what is V1 over here? V1 is V1, but V2 is 1 upon 5 V1, right? Over here. So it will become 1 upon 5 V1. It will gamma minus 1, so it is 3 by 2 minus 1 over here, which is equal to T2 by T1. So this one will get cancelled. So it will become 5 raised to power 0.5. Yeah. Is equal to T2 by T1. That's the answer. You can check it. It will be option number C. Yeah. I hope it's clear. Yeah. Okay. Any other questions? Okay. Thank you.